Hello and welcome to the OpenCL plugin video tutorial. In this video, we will present a short overview of the OpenCL plugin and its features. Afterwards, we will demonstrate the plugin usage with the example that performs simple array operations on 2D arrays. Finally, we will use the plugin to tune matrix multiplication code on the Intel Xeon Phi accelerator card. OpenCL plugin for periscope tuning framework selects the best combination of local work sizes for OpenCL kernels. The plugin tuning strategies define how the search space is constructed and explored. With the local tuning strategy, separate search space for each kernel is constructed. In this mode, the plugin aims to minimize execution time of each kernel in the application. Each kernel-specific search space may then be explored with individual or exhaustive search strategy. The global tuning strategy creates a cross-product of all kernel-specific search spaces and minimizes overall application execution time. XML-based NDRange tuning specification allows users to specify feasible local work sizes for each kernel in the application. The user may explicitly enumerate each scenario that is to be explored by the plugin. Alternatively, value ranges in the form of minimum, maximum, and increment may be provided for each NDRange dimension. In case both are provided, the selection is made via tuning spec attribute. The same configuration file is used to set the desired tuning strategy, which can be set on the plugin level to local or global, or to tell the plugin to use the exhaustive or the individual search strategy. If the local tuning strategy is used, plugin may be set to use individual or exhaustive search along NDRange dimensions. Each kernel-specific search space may be explored with a different search algorithm. When global search strategy is used, then exhaustive search will search across the space created as a cross-product of all kernel-specific search spaces. Alternatively, user may use individual search across all tuning parameters. Now let's try to tune simple OpenCL application. This simple application contains two OpenCL kernels that perform array addition and subtraction in 2 dimensions. Code has been already instrumented and contains functions that map concrete values for tuning parameters to variables in the code. For each tuning scenario that is to be tested, local work sizes are adjusted accordingly. In tuning specification file, we will use value ranges for tuning parameters to describe the search space. In global tuning mode, the search space is calculated as a cross product and amounts to 10,000 scenarios. With the exhaustive search, the whole search space is explored. The individual search strategy explores significantly fewer amount of scenarios and yet usually achieves similar or comparable results. For the local tuning strategy, the full exhaustive search will explore 200 scenarios. Each kernel-specific search space may also be explored with the individual search strategy. In the mixed mode, the plugin will explore 120 scenarios. Finally, if all kernel-specific spaces are explored with the individual search strategy, the total amount of scenarios to be explored will be reduced to 40. We will tune the application with a global tuning strategy and with the individual search to keep the search space smaller. Let us now tune the application. We simply pass the executable, the CO file, we select the OpenCL tuning plugin, and pass the tuning specification. Before the tuning begins, plugin presents the user with the configuration information, relevant information on tuning strategy, kernel settings, search strategy, and tuning parameter information. For each kernel, all OpenCL devices on the system are queried for maximum local work sizes. After the tuning is finished, the plugin presents the summary featuring total search steps, best executing scenario ID, kernel configurations of the best scenario, and the list of all explored scenarios. If we tune with the local tuning strategy and exhaustive search, the tuning objective will be minimization of the execution time of the kernels. Therefore, the plugin outlines configurations of the best executing kernels. For the matrix multiplication example, we use the code from Intel OpenCL SDK. The code has been instrumented to support tuning with PDF. In tuning specification, we have one kernel with 2 dimensions for local sizes. We will set the tuning ranges to go from 1 to 64 with variable step size. We will tune the application with Intel Xeon Phi acceleration card. The plugin explored 49 scenarios with the exhaustive search strategy. The best configuration used X local size of 32 and 1 in the Y dimension. It finished in 3.78 seconds. The total tuning time was 4078 seconds. With the individual search, 14 scenarios have been explored. Like with the exhaustive search, the plugin found the best combination of the local sizes to be 32 in X dimension and 1 in the Y dimension. The total time required for the tuning was 729 seconds.